Hi, my name is Peter Devine, and today I'm talking about a paper that I wrote with my colleagues at the University of Auckland entitled What's Inside a Cluster of Software User Feedback, a study of characterization methods. I think this paper is a small but somewhat important contribution to the field of crowd RE, and but basically what the paper looks at is user feedback, which can be tweets, app reviews, or any sort of feedback that a user is giving you on a given piece of software. We're looking at ways that you can summarize the topics that are apparent within that feedback. So, for example, being able to say to a requirements engineer, X number of people are complaining about this specific bug and wanting this specific feature. We are looking at the best way to communicate that, to summarize those requirements to a requirements engineer. First of all, I'd like to start by asking you to imagine that you are a Snapchat engineer. You are going through the tweets to the Snapchat support Twitter handle, and you come across this tweet saying that someone is having login problems. It may be because they have just written the wrong password, or they've chosen the wrong username, or it might be a problem with Snapchat's servers. This problem becomes clearer when you look at other tweets as well. So when you have a lot of tweets here, you can see that this is a problem for more people than just one person, and you might have to act on it. So as a requirements engineer, it's very useful to be able to have this sort of feedback all in one place, to be able to group all feedback that is mentioning similar problems or asking for similar features into one place. And many tools exist for this. So tools including Merit and Clap all are able to take a large amount of user feedback and then group them together into semantically coherent groups. So this works for both app reviews and tweets. And the thing that we are most interested in is how we can characterize these groups or these topics of user feedback. Because if you can't effectively characterize or summarize these topics, then they are somewhat useless, not useless, but it reduces the utility of these tools if you still have to go searching through lots of user feedback to be able to find what the actual topic is about. So an example of characterizing these topics can be seen here. So what we look at here are the tweets that we were just looking at for Snapchat. And we could summarize these tweets using either unigrams, which are words, using words like account, locked, unable, login, or we could use a sentence, is anyone's Snapchat permanently locked for no reason? And both of these have been used within the literature to summarize topics within user feedback. So both of them have pros and cons. So for unigrams, obviously single words are shorter, so they're less expressive of a given cluster. However, because there are more of them, they're able to potentially cover more ground over all of the pieces of feedback that are listed, all the pieces of feedback that are included within a cluster. For sentences, obviously there's only one, so it's only able to focus on or take the feedback from one specific piece of feedback. However, because the words are joined up in this sense, it is more expressive than disjointed unigrams. So some examples from the literature on how this has been done before include clap. So what I'd like to draw your attention to here is the C1, where it has 4 words that describe the feedback within this cluster. So crashes, crashing, tweet, application is the characterization for the 3 app reviews that are contained within this cluster. And these are just unigrams used to characterize this. And from looking at it as a developer, you could say, oh, okay, these reviews are probably talking about a crashing problem. So Stanek et al. Also provides the OpenRec fork. Last year's requirements engineering conference, and they took tweets from that were addressed to tech companies, and were able to cluster them into, again, semantically coherent groups, and these groups were characterized by individual tweets. So this was the characteristic tweet of this cluster. So the challenges of characterizing a cluster are that it has to be understandable at a glance. If you are a requirements engineer and you look at a cluster characterization and don't understand what the link would be between all of the pieces of feedback within that cluster, then it's not very useful. On the other hand, if you're a requirements engineer and you can look at a characterization and say, oh, okay, cool, I'm looking for this specific problem, or whatever you're looking for, if you can find it quickly with an effective characterization, then you're more likely to make good requirements and thus good software. So we posit that a cluster characterization should be both descriptive of the cluster content. It has to be able to describe what is going on, or what the feedback is saying in the cluster or the group. And it has to be distinct from other cluster characterizations. So, for example, if you are looking at app reviews of a WhatsApp app, if every cluster's characterization just says WhatsApp, it's obviously descriptive to some extent that they're all mentioning WhatsApp, but it's not very useful. And obviously then if you can't distinguish between the clusters, then it's not very useful for then generating requirements. So our approach, with our approach, we look at unigrams and sentences, which, as we've shown before, have been studied previously or have been used previously in clustering tools. But we also look at bigrams and trigrams. So bigrams are 2 concurrent words, and trigrams are 3 concurrent words that have been found within the text. And then we look at we have 2 main research questions that probe the distinctiveness of our cluster characterization methods and the descriptiveness of them. So for distinctiveness, we ask what characterization method is most easily able to distinguish a cluster compared to a random baseline. So we look at a cluster characterization and then compare it to another cluster characterization from a randomly sampled cluster, and see how often are we able to detect the correct cluster characterization. For descriptiveness, we look at what characterization method has the highest amount of requirements relevant information about a cluster. So which cluster characterization method is best able to relay the information, the requirements information of a cluster. So to do this, we look at 6 literature data sets, which cover app reviews, forum posts, and tweets. And we supplement this data with data from Spotify, from Twitter, Reddit, forums, and app reviews, so that we could have more information, more data from Twitter, from forums, and also allow a little bit of analysis of Reddit as well. First of all, we take each data set, we break the data set down into individual apps, and then we take the feedback from that app and we embed it using the universal sentence encoder. These embeddings are then, we reduce the dimensionality of these embeddings using the UMAP embedder, and then we finally cluster these resultant embeddings using the HDB scan clustering algorithm. So the UMAP HDB scan process is done by because previous state-of-the-art work has used this process. So we get clusters of feedback from this, and what we do is we randomly sample one piece of feedback from each cluster, and that is the representative of the contents of the cluster. For characterization, we first of all find all of the unigrams, bigrams, trigrams, and sentences that exist for that app in the feedback. We clean them, and then we embed the resultant n-grams and sentences, and we find the cosine similarity between the n-gram and sentence embeddings and the cluster embeddings. So what we do is we compare each n-gram to each piece of feedback embedding within a cluster, and then we total the cosine similarities, and we choose the most similar total n-grams and sentences. Finally, we choose the k most similar n-grams and sentences to characterize the cluster. So this is a really important point here, because k varies depending on the characterization type. So we set k to be 12 for unigrams, 6 for bigrams, 4 for trigrams, and 1 for sentences. And this is to keep the number of words contained within a characterization method, characterization type, the same. I think frankly, these clustering tools rely on an interface. At some point, a requirements engineer is going to have to actually look at an interface to be able to see what a topic is about. And there's limited screen real estate for that interface. So we wanted to see whether roughly the same space being taken up for unigrams or for sentences would be better, or for bigrams or for trigrams. So a little toy diagram for what our clustering looks like is here. Effectively, similar feedback is clustered into individual groups. And here's an example characterization that we then generate from our clusters. So these characterizations all mention the same, were generated for the same cluster, and they're all talking about login problems, or not being able to log in, problems with the account, and they do that to different extents here. So our evaluation was done with 2 tasks that were done by 3 labelers. The first task was a random characterization comparison task. So this is where we took the sample piece of feedback that we generated for each cluster, and then we compared it to the cluster characterization that we generated for that cluster. And then that cluster characterization was compared to the cluster characterization generated for another randomly sampled cluster. So we took the sample piece of feedback, the real characterization, and then a randomly sampled other characterization, and we asked the labeler to determine which of the two characterizations was the one that was generated for that cluster. The second task, and this first task was done to find the distinctiveness of the characterization, whether one could tell the difference between the generated characterization and a randomly sampled one. The second task we looked at was the requirements relevance labeling. So first of all, a labeler was asked whether the sample feedback was requirements relevant. Requirements relevant in this case we consider to be relating to bug reports or feature requests. And then if it was requirements relevant, then we asked the labeler to determine whether the characterization generated for that cluster was also relating to the requirements mentioned within the sample feedback. So this was done to determine whether the characterization was able to describe the descriptiveness of the characterization, whether it's able to describe the feedback within the cluster. So for our outcomes from our methodology, we got 160 clusters taken from 33 apps across all our data sets, and that's also across multiple feedback channels like Twitter, forum posts, Reddit posts, and of course app reviews. And our labeling intercoder reliability, we measure using Cohen's kappa. First of all, for the random characterization comparison task, we have 0.677, which stands for substantial intercoder agreement. As for the requirements relevance labeling, we have moderate intercoder agreement. Again, I think the difference between these two, I would personally say that requirements relevance labeling is slightly more subjective in that something that could be requirements relevant to one person might not be to another person to a greater degree than just asking which of two characterizations is most relevant to a piece of feedback. So our results from this, first of all, for the distinctiveness task, for the random characterization comparison, we look at, so each piece of feedback was labeled by 2 labelers, and 3 labelers did the labeling overall. And we look at the pair coder, either coder, or both coder labeling accuracy. We find that there's no real trend beyond between unigrams, bigrams, trigrams, and sentences. We all find that they're quite highly distinct, but there's no real meaningful trend between unigrams, bigrams, trigrams, sentences. However, for the requirements relevance labeling, we do see more of a trend. We find that quite a small percentage of unigrams actually mention the requirements that are mentioned within requirements relevant piece of feedback, whereas sentences, a much higher percentage do mention it. Although it is worth noting that that is still quite low in our evaluation. Only 45% of summaries mention the requirements that are in our sample piece of feedback, which I'll mention in a little bit. So, in a nutshell, our results are that all characterization methods tested were similarly distinguishable from other clusters. So, you're able to tell unigrams, bigrams, trigrams, sentences pretty much equally well apart. But when it comes to communicating the requirements information of the piece of feedback, we find that fewer but longer and more expressive characterization methods are more effective at communicating requirements than more but shorter units of characterization. So this has implications for future research in RE, in that we would ask if you're making clustering tools in the future for user feedback, that potentially using sentence level characterizations over unigram ones would be beneficial, even when the number of words is kept equal. But I think the most important question is that it opens questions for future research, or the most important part is that it opens questions for future research, especially things like extractive or abstractive summarization could be used here, where they could kind of marry the best of both worlds, where unigrams obviously cover more bits of feedback. You could use an abstractive model such as Pegasus to generate a natural piece of text which takes in information from lots of different pieces of feedback. So you would feed in all of the cluster, for example, and then get a model like Pegasus to generate a sentence-based summary, so something that is still expressive, but covers more of the information than just taking the sentence from one piece of feedback. So that's a field for future research, I think, but I think that could be quite promising and help requirements engineers further to use user feedback to make their requirements. So thank you very much for listening. Feel free to reach out at my email address or on Twitter.